All right. So we are broadcasting. I think that what we usually do is wait until maybe 5 after the hour and allow people to trickle in. And I see them starting to pop in already. And we'll remind everyone and welcome to those who are popping in to the participants view here. We'll wait a few minutes, maybe 3 or 4 after the hour, and we'll kick things off. But welcome everyone. I'm going to stand. I have a standing desk, and this is just a good time to stand and stretch my legs. And welcome again, everyone. I see people flowing into the attendee list. We are going to get started in just another minute. Thank you for joining us. We're just going to give another minute for people to pop in. And thank you for taking a KubeCon break. That's very cool. I will say, good afternoon, good morning, good evening, everyone. Thank you for joining. My name is Paula Paul. I'm a principal engineer with Grayshore, and I'm very also honored to be a Cloud Track lead for Women Who Code. I'm joined here by the Cloud Track fellows as well. So thank you for coming. We are going to record this session and share it broadly, but we always love the back and forth with people in the Q&A of this. So please join in. We'll be monitoring the chat and the Q&A. But it's my great honor to host Samia and Alpesh today that they've gone another step in their journey with data mesh, data product application by example. But before we get into the good stuff, I do want to let everyone know, sorry. I'm having a little trouble with my presentation here. Let me try to present again. Always the technical difficulties. And here we go. So Sorry, taking it from the top, I want to take a minute to share with you the mission of Women Who Code. A little less quickly. So our mission is to inspire women to excel in technology careers despite technology thwarting us sometimes, as with Google Slides. And our mission and vision is to see a world where women are represented at all seats in the table, all areas of technology, as technical executives, VCs, product owners, product managers, board members, software engineers, and especially data engineers, which we'll hear a little more about today. We do have a code of conduct, and it is available on the website. Encourage you to join us. Anyone is welcome. We're an inclusive community. Anyone that supports the mission is welcome in the community. We hope that you never have need to use it, but if for some reason you do encounter violations of our code of conduct, we do want to hear about it and we will act on it, and we appreciate your openness and support of the mission and vision. Special thanks to VMware, who has been a CloudTrack sponsor for some time now. And also, we are very active on social media. Please connect with us, share your stories. If you have a story and you're interested in speaking, please reach out to me. I am Paula at paulapaul.com. So it's easy to remember, and I'll also put that in the chat. And then with that, I'm very, very pleased to turn this over to Samia and Alpesh and to hear more about their journey with data mesh. And sorry again for the technical difficulties getting this going. So I will stop the share and allow Samia and Alpesh to do some sharing and regale us with their tales. Welcome.
Hi, I'll quickly introduce myself and hand off to Alpesh. So I'm Samia Rahman. I presented the data mesh application, data mesh example for infrastructure last time with Marco, and this is the next segment to the data mesh architecture, which is the application. I work for Thoughtworks as a lead developer and have been with them for about 3.5 years, and I'm joining you guys from Chicago. I will hand off to Alpesh.
Thank you, Samia. By the way, I also work for Thoughtworks, and I do a lot of work with data engineering team at Thoughtworks. So let's get started with our data mesh application by example. In today's session, we are going to see how can enterprises unlock business value from their data without much friction using the data mesh architecture. So we'll go ahead and get started. This is something what we recognize as cycle of intelligence. And the cycle of intelligence goes like, if you want to unlock the value from the data, these are the typical steps and the cycle you go through. You acquire the data, you clean it, you model it or enrich it, and then you kind of productionize either your machine learning models or visualizations or dashboards. And then the next step is typically you take some action from the insights you are getting from your data. And it's not a one-time thing. That's why we call it a cycle. You continuously can do that on repetitions and get better at it. But we have also seen a lot of failure modes and how a lot of organizations struggle to get this cycle correct. And we are going to see how this gets composite or packaged up in a data product, but what we call data product in the later slides. So to unlock the value from the data in the enterprises and large organizations, I'll go back in the history a little bit. Many years ago, people came up with this concept of data warehouses where people realized there was a need to collect the data from various systems you have and create a uniform view of the data. But mainly it was driven by the need to visualize the data in some form of like dashboards or charts and diagrams and things like that. It worked for quite a while until it didn't work. And people started realizing there was no way to realize the value out of data where there is no structure. For example, if you have unstructured data and images and videos, and what do we do with that? So that's where the big data platforms came in. And now we have ability to process large amounts of data. It doesn't have to have structure. There doesn't need to be any relation across data sets to really perform any analysis. So that kind of boosted this entire revolution around the data lakes and data platforms to be that big data platform. And then on top of that, we started to see this cloud revolution as well. So cloud gives you the scale of storing large amounts of data and processing large amount of data without virtually no limitation at all. With that, we started to see these huge data platforms where people have all kind of data. And the problem with that is you have data that no one is using, or no one has any idea how to use that. Or even worst case scenario, no one even knows it's there and no one is governing it. So that's just the tip of the iceberg we started to see as a problem. Then we dig a little bit deeper into what is causing these problems and why are we running into this, what we call the data swamps from time to time. So what we see as a pattern is people, typically a technology team or IT team, will try to organize their data platform to avoid this kind of data swamp and chaos. And because them being technology people, they will try to organize the platform by the technological segments of the platform. So they will have some kind of ingestion segment, they will have a processing layer or layers of processes, and then they will have serving model where they have like data marts and reports and machine learning models serving data and APIs and things like that. But with this, we also started to see a lot of silo in terms of the technology and the architecture. There is no cross-functional view of enabling the domains or the business use cases across this horizontal slice of the entire platform. So that's one problem. The another problem we started to see is the teams, those are working within their silos, they start to get very specialized on their technological segment, but they lose the sight of what is the domain, or what are the personas they are supposed to serve, what are the use cases, what are the usage patterns. That's something they start to lose sight of, and they work towards the technological advancement excellence, which is great. But at the same time, if there is no business value, then the entire model starts to break down. And because of that, we also start to see a lot of siloed ways of working where people are preparing the data, they have artifacts or data, they just throw over the world to the next segment without worrying about how useful it's going to be. And that kind of starts to mirror into the organization structure as well, right? So you have the siloed team that reflects from your siloed architecture, or vice versa in some cases, but you have this cross-functional domain teams, but these domains are very vertically sliced. So you have teams, those are sourcing data from external systems, or your transactional system teams, those are working on processing data like machine learning teams or data scientists, data analysts. And then you have consumer teams who are building dashboards or applications on top of the data, but they don't collaborate with each other to unlock the business capabilities, the domain capabilities, or the business use cases. Now, so we started thinking about these silos and how do we break them down. We took some inspirations from other architecture models in the software engineering world. And eventually we came up with this idea, what we call the data mesh architecture. So the key difference we identify from the traditional data lake or data platforms and the data mesh architecture is the domain becomes your first class concern. Here we identify domain as something that you can express in terms of the business, and people can identify with to express the data. So instead of your vertical slice of your technological area, now your first class concern is serving that domain and understanding that domain intimately so that you can really serve the personas of those of that particular domain that you're working in. And typically we see this domain being a composite of one or more what we call the data products. So now your data is served as a product. It's not just, you're not just serving the data, but you need to enable all the features around the data that actually makes consumption easy for your users, which includes the explorability, the addressability of the data, and all the features that we are going to list in the later slide. But data itself is, you're not just serving the data in the raw format or processed format, you're serving it with a package that makes it consumable as a product. And now, because we are building these domains, those are decentralized, those are federated, how do you ensure that they are built consistently and you have ability to scale in terms of developing this data products and unlocking these domains? And that's where the self-serve data infra comes into picture to enable that consistency and scale. The data infra is supposed to be that layer between your core infrastructure and the data product development that enables all the developers and the owners of the data product to build these products consistently and quickly enough to scale to meet those business requirements. And the another aspect is the federated governance. So you obviously need to have that governance to address the key concerns, like how are we going to model these domains? How are we going to set up the access control around the data? Who can see the data, who cannot see the data, and all those concerns. We see this more being federated by domain, like case-to-case basis, but at the same time, the self-serve data infra provides you capability to keep it consistent as well. So you need to have certain, like, non-negotiable guardrails. Those are offered by the self-serve data infra, but the governance and defining the rules is federated based on your domain, or even sometimes at the data product level. And at the bottom, what you see here is a self-serve delivery infrastructure. This is where your CI/CD pipeline and the execution environment and things like that. Either it can be abstracted out by self-serve data infra, or sometimes we see developers directly interacting with that as well. So I will now move a little bit into the domain-driven design. And a domain is basically a language of expression to express your data with some common understanding and terminology in a way that people can understand and consume the data. So defining the domains around your data, it's very important to make it consumable. And this is where the technical architecture and the business domains come together to define those domains. Those domains should be reusable enough to fulfill multiple use cases and needs of various personas that you have for your data. This is where the technology and domain experts will collaborate with each other to really identify the boundaries of the domain and how they're going to play with each other in that, what we call the data mesh. And also the domain defines a common language, how the data is expressed. So for example, in case of, if you are an insurance company and you have insurance claims, what you call online claims, that kind of becomes a unified language that everyone can refer as. What you call a call center claim, that becomes a terminology that everyone can use and everyone can identify with. And this also goes not just at the domain or the data product level, but it also goes at the individual attributes level, and what you call those attributes consistently, that makes your terminology, your domain, much more consumable by end users. And then here we also want to call out one thing is that you need to design your domain carefully enough that you also enable not just the application and visualization use cases, but you also unlock the exploration and experimentation use cases. So I'll zoom into what is a data product. So because a data mesh is a composite of multiple domains, and a domain is made up of one or more data product, right? A data product is truly data served as a package that is consumable by the user. So to define the boundary of a data product, we start with the input data ports. Input data ports is how does the data come to your data product. It can be batch process, which gives you the data like a file system or SFTP server. It can be a stream like Kafka or stream sets, or it can be a set of APIs where you're calling and scrapping the data. Or in some cases, it can be a push mechanism where upstream system is pushing data to you. And then the other side of the boundary we see is the output ports. How does the data product serve data to its consumers, and consumer being either humans or systems? So either it can serve as a batch data where like someone like a data scientist can explore those files from the batch output and use it for their analysis and machine learning purposes. It can be a SQL output where the visualization, like dashboard people, they can create dashboards and visualization, or it can be an API which can be consumed by a downstream application to get the data. Or it can be a stream as well, which the downstream consumers can subscribe and continue to listen to those streams. So those are the various input ports and output ports. We also identify something called what we call the control ports. Control ports are features, those are commonly available across different data products, and you have this consistent experience of interacting with data products. And then every data product should have some common features. So it should be discoverable, it should be addressable. Addressable in the sense like it has a unique name, people can identify what is the data product, where is my data product, people can talk about it with each other and sort of kind of give reviews and things like that, right? It should be self-describing. If you are looking at a data product on a discoverability capability, then you should be able to see what kind of data does it provide, what is the lineage guarantee, what is the data quality guarantee, how do you access the data, whom do you need to request the access for, and things like that. Of course, it should be trustworthy, and it should have its own SLAs for data quality and refresh rate and things like that. And we already talked about the federated governance, but this is where the security comes into picture, where even at the data product level, the governance people can define who can access data and who cannot access data. And then it should be interoperable. So we highly recommend you keep your data products loosely coupled with each other, so you have ability to integrate across domains, across multiple data products without much friction. Now we'll dive into an example that Samia and I worked on recently. So here, our domain is culinary domain, and because we like food, who doesn't, right? So, and then we have identified two data products to form our domain. We have at the left side of the diagram, you see the NYC restaurant data product. That data product serves the data that we have sourced from publicly available data sets. So we have 4 different data sets that we have identified. We ingest the data and then we serve it as we have received without making many changes. We do some minimal harmonization of the data, but we don't make any changes to the data itself. Now we serve the data into 2 different output ports. One is a file output port for data scientists to explore this data. And then the another is a SQL output port, which we are going to use for our downstream data product, but it can also be used by a data analyst to create visualization or dashboards. Our downstream data product, it's more specific for a particular use case we want to serve. And here we want to create a report where we can identify new dishes popping up on year-to-year basis, and what are the dishes that those are disappearing from the menus from time to time or on year-to-year window. And the output of the downstream data product, again, it's the SQL output port where the data analyst can use it to create visualizations. So 2 data products, and in total we have 3 output ports. 1 is designed for the data scientists, and 2 of those output ports are designed for the SQL output. We also want to call out one thing, that the NYC restaurant data product, it is something we call the source aligned domain data product, where the domain is expressed in the same language as the source. expresses, and we didn't change the language of the data set itself. We developed that particular data product to keep the data reusable. And also we plan to add more data products in future from various cities and geographies, so that our downstream data product will be richer as time passes, and it will have ability to mature. And that's part of the reason why we segmented this domain into 2 different data products, so that we can scale this domain later on. Now, based on this example, I want to go through how do we start with developing a data product if I want to start with completely fresh new domain. So the first thing we need to do is identify the usage pattern and who are the people who is going to use this data. So in our case, we identified one usage pattern, which is this report, where we expect the data analyst to create some visualization. So we have 2 personas to serve. We have a data scientist who would like to access the raw data that as it is coming in from the source system. And we have the data analyst persona who would like to use the SQL output port, but more in an aggregate form and not really the raw form. So those are the 2 personas and the use cases we have. Then we identified the sources of data. So like I said earlier, we are sourcing this data from the publicly available data set, and Samia is going to go into details for that. Next step is to explore the data. So we identified the relationship between data set, how good the quality is, how frequently are they refreshed, and things like that. And then we identify the data products that we are going to develop to compose our domain. So we identified 2 data products for now, but in future we plan to add more data products. And that's why we are keeping these 2 layers or data products separate in our domain itself. And then finally, you define your input and output ports. So input and output ports, sorry, I'm jumping back and forth in my slides. So your input and output ports define your contract, your boundary of the data product. And in our case here, sorry, I forgot to put the input to the NYC restaurant data product, but input ports are really the batch files that we are sourcing from publicly available data sets. And the output ports are, for the upstream one, there are 2 output ports, and the downstream one only has 1 output port. But that's the boundary or the contract that we have defined for our data products. And by this definition, then you have enough information to start developing your data product. So this is more of an inception journey rather than the development journey. And at this point, I will hand over to Samia to go into implementation details.
Sure. I assume everyone can hear me? All right. So based on what the logical view and the data product definitions that Alpesh just defined and outlined, one thing that as a data product developer we see is we need to at least understand the basic infrastructure elements that are involved in our data product and how the runtime application layer will operate on that infrastructure. In our use case, we are implementing with Google Cloud Provider services, which we had demoed in the previous webinar, and there was a lot more details around how their infrastructure gets provisioned and things that need to be accounted for. So I will quickly go over what I should care about as a data product developer when understanding the infrastructure layer so that I can focus on my business logic and get that data product out. So mapping this back to what Alpesh showed, the NYC restaurant data product would have that input port that we discussed that's ingesting files. So we would have a storage bucket from Google Cloud Provider or from GCP. And then we need the processing layer where my transformation logic would run. And on the left-hand side data product, you can see we would need a temporary storage bucket. So that data flow, which is our choice of processing engine, it's using Apache Beam from Google Cloud. And those two things need to be available for my processing needs for my data product. And that's where I would see the logs and see the runtime of my application code. And then I also need an identity for my data product. So in infrastructure, when it gets provisioned, we should get an application service account for ourselves. We call this DP1 service account, via which we should be able to read data from the input storage, run it against data flow, and then finally serve up the data on the output ports. So the output ports in our case, mapping to what Alpesh had outlined, would be the input, it should be labeled as output storage. It's a storage bucket to map to the file output for our data scientist personas who might want to explore in Parquet formats, Avro formats, etc. And then a second output port, which would be the BigQuery dataset port, mostly for our analyst personas. In GCP, as a data scientist, I could also explore the data on the BigQuery dataset. And in our example, we're going to show how some of the data pipeline design will utilize both, and the logic might be slightly different on the two. And finally, in order for this data product to be whole, going back to that unit of architecture of a data product, we need to ensure that our data product is discoverable and we're describing our data product. So in that case, we would also need the cloud data catalog from Google Cloud. And then in order to govern access to this to these outputs by our downstream data products or downstream consumers or downstream systems, it could be machine learning models or reports, their identities need to be granted permissions to read from our BigQuery dataset and our storage buckets. So you would bind the access control and govern it via an AD group. So that kind of outlines the first data product that we saw in the logical overview in the previous slides. The downstream data product that we had identified in our case would be the Culinary report data product. And in that one, I don't really need an input port or a physical service from GCP to provision an input port, because my input port for the Culinary data product is the output port of the NYC restaurant data product. So my service account or my identity for this data product would be granted permissions and added to that Google group that governs those outputs. And then similarly to the NYC restaurant data product, I need the basic processing layers. So again, I need some storage buckets for my processing via data flow. And I need to publish my output metadata for the very custom reports that I might be generating and publish that in the catalog so that the various personas can discover this data product. And I would be outputting my processed and the business logic I've applied to that data and put it on the BigQuery data set, which would then be accessed by analysts and governed through that Google group that governs it. So that kind of gives us the high level of what the basic infrastructure layout looks like and the parameters I would need to know in order to run my data pipelines and encapsulated in these data products successfully. So now that we've established this baseline and have a high level overview of what infrastructure pieces are involved, we can then start thinking about our data pipeline design and what is the overall, the core thing that we care about. What does the business logic look like? So on the next slide, you'll see the NYC restaurant data product. Alpesh, if you don't mind clicking on the next slide. Thank you. So on this slide, we're focusing on the NYC restaurant data product. And in our design, because we took open source data files for NYC restaurant data, which had menu items, menu pages, and dish files. We need to ingest each of those files and then do some cleansing logic. So all of that is going to be running in parallel. And then finally, we would want to write it to the output ports or to our output storage bucket with all those files being persisted. So all of that can happen in parallel. And as soon as the cleansing is done, the other thing we identified was for that BigQuery data set, it would be nice to have a denormalized view where you can join all of these files and give a denormalized view for your aggregate computations or smart dashboards that you want to build out of that denormalized view. That way, your analysts or your downstream data products that are going to utilize this denormalized view, they don't have to repeat the denormalization logic every time. So this would be the other processing layer that we would put. And then once that's done, we would then write it to the BigQuery data set. So this can happen in parallel as soon as those previous records have been, or the previous stage of record cleansing has been completed. And then, so that kind of shows us what the NYC data pipeline design will look like. And then to zoom into the Culinary report one, which is the downstream data product, on the next slide, Alpesh, if you don't mind moving on to the next slide, thank you. On the next slide, we see the Culinary report data product where we are reading the data directly from BigQuery dataset, and then we would apply some windowed aggregations of how many new dishes per year and how many dishes are disappearing every year, some smart aggregate logic, and then write it out to a BigQuery dataset. So by now we should have like a good logical set of action items for as a data product developer around how I want to go about and implement some of this logic. So now we'll move on to looking at the actual demo where we'll zoom in on the NYC restaurant data product, and I'll go over some of the details in terms of how the code logic looks like. So bear with me as I start sharing my screen. I assume everyone can see the right code. Let's see. All right. So we're using, for the NYC restaurant data product, I have a main data product processor, and the main function will set up my various arguments that I need in order for my data product application to run. The arguments that are going to get set here are going to be the various input files that I'm seeking to ingest and the corresponding schema files with them so that I can apply the cleansing logic, put the correct types, etc. And then finally, any additional parameters around outputs and delimiters in terms of how I parse those files. So these pipeline options get passed via the arguments, and if we had a CI/CD pipeline, we would put the command line options just as we would demo in our current session. So once we've gathered those pipeline options, these are libraries from Apache Beam SDK, we would then go about writing our actual logic. So I'm going to go into the main processor, and initially I'm just setting up some of my schema, the schemas that we had defined as parameters, and then we do some basic field type checking to ensure the formats, etc., are correct. And then we go about applying the converting the CSV lines from each of those files into appropriate records with the correct schema. So you'll see I'll have all those 4 files that are being processed, and they will happen in parallel. And then as soon as each of those finish, they can also be written out. In my example, I'm using the Avro format and writing it out with an Avro sync with the appropriate schemas so that it gets to my output port correctly. And then finally, in order to do the denormalization we were talking about, in this example, I did a very basic denormalization around menu items and dish IDs getting denormalized. There's additional work around denormalizing it with the menu data and the menu the menu data and the menu page data to get a full 360 view or a full 3D full denormalized record, but for our demo, I kept it simple for now, where I just join these dish ID and menu item records, and they get grouped and and aggregated, or sorry, joined accordingly, and then we finally write it out to our output port. There is one thing that I didn't have time to add was around writing to the BigQuery, writing the denormalized view to the BigQuery dataset itself. But if we had more time, we would have additionally added that section of the code as well. So this kind of shows the data flow pipeline design that we talked about earlier in the previous slide around the NYC restaurant data product, and shows how we've organized some of the code. And when we run it, we expect the data pipeline to get, or the data flow process to get started. So I'm going to go ahead and run the data flow application, or this application, so that we can see some outputs at our target output, the storage output container. So you'll see, in order to run with Dataflow with Google Cloud's Dataflow service, we specify our main class and then the various parameters that I had mentioned earlier, the input file, the schemas associated with them, and then the target output directory, which is DPA output. So this is where we'll demo that, hey, the files do end up where they should end up. So I'll get this triggered. It takes about 3 to 4 minutes to run. So while that's running, I will quickly move into showing the data pipeline getting triggered on Dataflow. Bear with me, a bit of screen swap. All right. So we expect a data pipeline getting triggered based on the command that I just invoked. And you'll see it's been triggered, and it took about 4 minutes to complete in the previous sessions that we had done. While it's running, I will talk about some of the other elements, but you'll see at the end of this job process, we expect our files to come at DPA output, and then I have a sample, a simple Jupyter notebook to show the data scientist personas exploration of this data. So I'm doing something very lightweight in here in this notebook, where I want to fetch all the outputs, and then I want to look at that denormalized view and just print out what the data is there. And then I would, ideally, as a data scientist, I would do some aggregations, etc., which is something we're not going to demo. But while the job is running, I wanted to touch on some of the elements that Alpesh had outlined around the interoperability aspects and the downstream data product that we haven't really showed the code for. some of these additional features would be for the NYC restaurant data product itself, we would have some kind of orchestration. So a lot of people ask, hey, we don't have an orchestration layer. How would that get packaged and incorporated in the unit of a data product? So we see that the orchestration logic around scheduling your data pipelines or putting in any smart orchestration logic via Airflow, for example, in GCP, would get captured in the same folder as your data product, and you would deploy it as a composite unit of a data product. So in that deployment for that data product, you would first deploy your data flow jobs, and then you would go on to deploy your orchestration layers so that everything is fully configured. Some other things that we haven't really touched upon, and these are things we hope to show in the in future webinar sessions in terms of demos, would be the publishing of the metadata. So there's certain pieces of metadata that we would want to publish directly from the processing layer, specifically around your error quality or the quality of your data products outputs. What percentage of data was successfully processed and what percentage was eliminated? So in that cleansing logic that we had seen, there are going to be a few records that we're going to ignore, or there are going to be columns that are going to get ignored. Maybe some of the contracts that we've established in our processing logic for the incoming data might fail. So those kind of metrics and quality details would be something that we would want to produce and capture in our catalog so that our consumers can consume that data with a degree of confidence. And then the other element that we didn't really touch upon was, let me quickly go back into this presentation view. So for the Culinary data product itself, when it is, when it is ingesting the data from the upstream data product, this is where we would want to account for interoperability. We want to stay decoupled. So when it comes to interoperability, we wouldn't want to directly bind to the physical address of this BigQuery dataset or this input storage location, such that when this data product is evolving, or let's say the infrastructure team and the data product team has migrated some of these physical locations, our upstream data product is unimpacted by those changes. Another thing around interoperability would be the version of the data product. So when I'm building out this Culinary report data product, I would want to pin to a specific schema version and the output version of this data product where a specific business logic or cleansing logic is being applied. So when it comes to data product versioning and the schema versioning, we would want to access those details via some abstract APIs or some interoperability APIs that serve up those pieces of information of this NYC restaurant data product. And I will pause there to quickly switch back to see if our project ran or our data flow pipeline ran. All right, looks like it got completed. So if I refresh on the output, you'll see all the files got persisted here. And as the data scientist, we should be able to see the list of files and then explore through one of the files. So I'm going to quickly load up that denormalized view, which I've downloaded, and then you should be able to see these are the dish names, these are the various IDs and other column values that were in those files. So this kind of gives us a glimpse of how the data scientists would explore this data product. So it looks like we have a little bit of time left. I will quickly try to summarize based on that demo. on the final key points. So what we just saw was just the NYC, one of the data products, and how the consumers might explore that, and some of the elements you have to think about when you are implementing that data product. From this webinar, we hope you take away some of these key points. One is treat data as a product with domain as that first-class citizen. Think about your consumers who need to know what the domain is, and they care about that quality of data so that their burden of exploring that data is minimized. So when you have, let's say in an enterprise, you have 1,200 data scientists, and everyone is going to go and have to apply the same cleansing process. It's a lot of wasted effort. So creating these cleansed data sets and denormalized views helps the customers, which are the data scientists and the analyst personas, whose customers would be to solve those business problems that are solving the end consumers of the enterprise products. So treating data as a product has a lot of value, and we should also think about some of the metrics around measuring whether our data product is effective. So for this NYC restaurant data product, we would want to measure how many consumers are actually using and exploring this data. Is it actually valuable, or there's only one user who explored it once and didn't even bother to use it in a production model, let's say. So those are some kind of metrics you would want to establish when you are establishing a data product, and monitor and engage with your consumers. Hey, what do we need to do to improve the quality of this data product so that it's solving and unlocking multiple business problems in a rapid fashion? Some other things that I touched upon during the demo was around the orchestration and continuous integration aspects, but we didn't really dive deep into it. These are things we should all be thinking about, whether it is data pipelines or some other microservices-based application, which is around the testing. The testing in the data product or in the data context would be around that business logic, and then you would also want integration testing, and then the contract testing between two data products to ensure you're not breaking your downstream consumers, etc. So there are many elements to testing, and the same test pyramid that we would apply to any other system gets applied in the context of data as well. And then in terms of logging and traceability, this is something we've seen that it's a bit hard to trace, or there is a desire to trace how the data was ingested, processed, and output, and then consumed, and you want this correlation across your across the different platform services you're using to achieve the overall data product. So logging and traceability really helps you as a data product developer to maintain and support the data product. So think about what are some correlations you might need to maintain in order to ensure you can fully support that data product. And then finally, we didn't really demo error data handling, but when you're doing error data handling, you would also want to persist your error data frames and put them in a storage bucket so that you can reprocess and correct for it. So when you're processing large volumes of data, let's say gigabytes or terabytes of data, not all records will be successfully processed. So that percentage that didn't get processed correctly, you will want to park it in a interim storage bucket so that you can reprocess later. And then quickly to touch upon the usage of the data product by users, we talked about the interoperability aspects, and over there, be mindful of how you version your data product and those quality metrics that you want to publish for your data product so that consumers can consume your data in a confident manner. And I won't go more over interoperability, but we cannot emphasize, or we would would like to emphasize strongly on interoperability is really key in achieving the overall mesh where things can evolve independently and you're not tightly coupled to physical addresses. So that way your data products are rapidly solving and churning out those improvements and solving those business problems at the end of the day. Thank you for your time, and I will hand back to Paula for our questions that we might have on the channel.
Oh, thank you so much, Samia and Alpesh. I think we have a good question here in the chat, and then also some links to share with everyone who's joined. Thank you again for joining. It's a great question. So it's about discoverability. So how would you make the data products discoverable? What would be a proper tool to address discoverability?
We have not found a good tool yet. We have tried few options like Apache Atlas and a few other cataloging capabilities and things like that. We also explored the API registry as one of the options. In one of the clients where we are actually implementing data mesh, we ended up implementing a custom solution altogether. So sorry, it's not a very good answer, but most of the exploration tool we come across are more of data exploration tool rather than a product exploration tool. We would lean more towards some kind of product, a combination of product registry and a catalog together. In the way we envision this is more something like the way Kaggle presents you the data, where you can actually go and look at the data and look at the description of the data and what is the quality and things like that. But that would be a starting point, but we still need to mature that capability.
Yeah, it's sort of interesting to me from a holistic perspective because if you think about restaurants, maybe there is a product that's an information product, but there's also capability products that expose ways to order or, you know, find out what their hours are and these kinds of things. So it comes kind of into the realm of how do we expose products in general that there's capabilities those products provide and information. So it's a fascinating subject. Have you kind of thought about the software, like you mentioned API registries, how those might extend the mesh in general?
Yeah, so we recently had a discussion around in that cycle of intelligence, if we go back to how these data products feed into our, let's say the machine learning systems, right? And then those feed back into your application systems that are more consumer systems. You would want an interoperability pattern there around the data products interoperating with your ML models and then that interoperating with your application models. So we are starting to see the need for some kind of interoperability standards within that cycle of intelligence as well. Those are certain things that are being explored in terms of how this data mesh architecture goes beyond just unlocking the value for your data scientists and customers, data scientists and analysts. Sorry.
Yeah, and then it is almost a full cycle because those applications generate more information that feeds back into the models. Yeah. So it's a circle of life.
Yes.
And we have a lot of thank yous in the webinar chat, and it is great. We're coming up to the top of the hour. And I will express my thanks again. This was a terrific presentation, and links to the first step are in the chat as well. We'll publish this video. And I think that wraps it. Thank you so much. And thank you, Women Who Code. Cheers, everyone.
Bye.
Bye.